Hello guys, welcome to your channel Learning Point. Today we are going to see exercise 4.1 of application of derivatives, which is a part of your 12th commerce new syllabus. Now in exercise 4.1 it is based on the equation of tangent and the normal for the given equation of the curve. Now this over here is the equation of the curve. We start by writing over here, let px1 comma y1 is equal to 1 comma 3 given equation of curve is y is equal to 3x square minus x plus 1 and differentiate this with respect to x. So in such a case, derivative of y is dy by dx, as we all know. 3 is the coefficient and derivative of x square is 2x minus derivative of x is 1 and derivative of 1 is 0. So I get over here, therefore dy by dx is equal to 6x minus 1. Now slope of tangent is dy by dx at x1 comma y1. So I can say over here this is equal to dy by dx at 1 comma 3. So over here we substitute the value of x as 1. So I will get this is equal to 6 into 1 minus 1. So I get the answer as 5 for the slope of the tangent. Now a very important point, normal is always perpendicular to tangent. Therefore slope of normal is equal to minus 1 divided by the slope of tangent, which is minus 1 by 5. Now when I want to find out the equations, so we will say over here, for equation of tangent x1 comma y1 is equal to 1 comma 3, as we all know, and the slope of the tangent is 5. Therefore y slope point formula, y minus y1 is equal to m into x minus x1. Therefore y minus 3 is equal to 5 into x minus 1. So y minus 3 is equal to 5x minus 5. Take these both elements on the opposite side, so their sign will change, and you will get over here 5x minus y minus 5 plus 3 is equal to 0. So that becomes our required equation of the tangent. Now let us apply the same procedure for the equation of normal. For equation of normal, again x1 y1 will remain the same, 1 comma 3, but m will become negative 1 by 5. Once again we will use the same formula by slope point formula. It is y minus y1 is equal to m into x minus x1. Therefore, y minus y1 value is 3 and multiplied by x minus x1. So it is 1. Therefore, minus 1 into x is minus x. Minus 1 into minus 1 is plus 1. And this 5 is cross multiplied over here. So you get 5y minus 15 minus x minus 1 is equal to 0. In fact, plus x. So just rearrange the terms as per our required order. X plus 5y minus 16 is equal to 0. That is our required equation of the normal. Sum number 2, it says 2x square plus 3y square plus 5 is equal to 5 at x1 comma y1. Once again, as we did in the previous case, let x1 comma y1 is equal to 1 comma 1 and equation of the curve. So the equation of the curve, 2x square plus 3y square is equal to 5. As we did in the above case, differentiate with respect to x. I will get derivative of x square as 2x and this 2 over here is the coefficient. Same way, derivative of y square is 2y into dy by dx and the coefficient is 3, which is kept as it is. Derivative of constant 5 is equal to 0, so we just leave it as it is. 2 into 2 is 4x, which gets transferred on the opposite side with a minus sign, and this 2 into 3y is 6y is equal to 4x. Divide this 6y on the opposite side, so I will get dy by dx is equal to 4x upon 6y, and therefore students, dy by dx is equal to 2x upon 3y. Now, like we did in the above case, slope of tangent is equal to dy by dx at x1 comma y1, which is again dy by dx at 1 comma 1. So in place of x and y, we substitute the values as 1 and 1. So I can easily say slope of tangent is equal to, that becomes 2 by 3. Now the slope of the normal, we say that normal is perpendicular to tangent, therefore slope of normal is minus 1 upon the slope of tangent, that is minus 1 upon 2 by 3, which is equal to minus 3 upon 2. Now equation of tangent. X1 y1 is already known to us to be 1 comma 1, and the value of slope of tangent we have already calculated that to be 2 by 3. I guess it should be negative over here. If this is negative, minus and minus, this should become plus. Sorry guys, slope of tangent is negative 2 by 3 over here. So y minus y1 is equal to m into x minus x1. Therefore y minus y1 value is 1, m value is negative 2 by 3, and again it is x minus 1. So I can say that cross multiplying this 3y minus 3, and multiplying minus 2x inside the bracket, minus 2x and plus 2. Now take these elements on the opposite side, so their signs will change. So you will get 2x positive, minus 3 minus 2, that becomes minus 5 is equal to 0. In the similar manner, for equation of normal, the value of x1 y1 is again 1 comma 1, and the slope value over here is positive 3 by 2. So I can say by the slope point formula, y minus y1 is equal to m into x minus x1. Therefore y minus 1 is equal to m is 3 by 2 multiplied by x minus 1. Cross multiply this 2 on the opposite side. 2y minus 2 is equal to 3x minus 3. Take these both elements on the opposite side. So you will get over here 3x minus 2y minus 3 plus 2 is equal to minus 1 is equal to 0. So guys, that becomes our required equation of the normal. For sum number 3, the equation of the curve is given to be x square plus y square plus xy is equal to 3 at x1 comma y1. So as usual, we will first say over here that let x1 y1 is equal to 1 comma 1. Then we say that the equation of the curve is x square plus y square plus xy is equal to 3. Now like we did in the previous case, once again we will directly take the derivative of this particular function. Differentiate with respect to x. Derivative of x square is 2x. Derivative of y square is 2y dy by dx plus xy. So it will be multiplication rule between x and y. So it is y into derivative of x, that is 1, plus x into derivative of y, that is dy by dx, that is equal to 0 because derivative of 3 is 0. Now we take these both terms of dy by dx together and the terms independent of dy by dx on the right hand side with the change in their signs. So we will get over here, therefore y plus x minus y minus 2x. Therefore in the numerator I take out minus common, minus of y plus 2x and it is y plus x. So that becomes our required derivative of the given function. Now the given point that he has told us is x1 y1. We substitute this value of x and y, find the equation of the slope of the tangent. Dy by dx at x1 comma y1 at 1 comma 1. So substituting, you get minus 1 plus 2 divided by plus 1. So you get this is equal to minus 3 by 3, which is equal to minus 1. So we are ready with the slope of tangent, which is equal to minus 1. Now I can get the slope of normal, which is equal to minus 1 upon slope of tangent, and I can write the reason. Since normal is perpendicular to tangent, therefore minus 1 on minus 1, which is equal to 1. Slope of normal. So now the slope of tangent, slope of normal is available. X1, Y1 is also available in the given question. So now I can go for equation of tangent. X1 comma Y1 is 1 comma 1 and the slope of the tangent is negative 1. Therefore by slope point formula, y minus y1 is equal to m into x minus x1. So y minus 1 is equal to minus 1 multiplied by x minus 1 minus x plus 1. Take these elements on the opposite side. So x plus y minus 1 minus 2 is equal to 0. So that is a very easy equation for the equation of the tangent. Now equation of normal. Once again x1 comma y1 is equal to 1 comma 1, but what is the slope of the normal? It is 1, so I get m is equal to 1. Therefore y slope point formula, y minus y1 is equal to m into x minus x1, and therefore y minus 1 is equal to 1 into x minus 1. Therefore y minus 1 is equal to x minus 1. So in that case, minus 1 and plus 1, they get on the same side, it will get cancelled off. Subtract this y on the opposite side, so I get the equation as x minus y is equal to 0. That is our required equation of the normal. So now question number 2 says, find the equation of tangent and the normal to the curve y is equal to x square plus phi, and the condition is that tangent is parallel to the line 4x minus y plus 1 is equal to 0. Let us understand this case with the help of a small diagram. Suppose if I consider this is the required curve whose equation is y is equal to x square plus phi. If suppose we have a tangent doubly touching the curve at this point, and there is another line which is parallel to the tangent. The equation of this line is given to be 4x minus y plus 1 is equal to 0, and the normal is actually perpendicular to the tangent. So this is our required normal. So we need to find out the equation of the tangent and the equation of the normal. Equation of the curve is known, and equation of a line which is parallel to the tangent is also known. So how do we do this? Let us understand this. We first of all start by considering over here, as we did in the previous case also, let px1 comma y1 be a point on the curve where tangent is parallel to line 4x minus y plus 1 is equal to 0. Now slope of tangent is equal to dy by dx at x1 comma y1, as we all know. So we have to find the derivative of the given equation of the curve. So I will say equation of the curve is y is equal to x square plus 5, and I differentiate this with respect to x. So I will get dy by dx is equal to 2x plus 0. Therefore slope of tangent is just 2 into x1. Give it as equation number 1. What have we done? We have substituted over here the value of x as x1 because we are assuming that point x1 y1 is the point on the curve. Now, after getting slope of tangent as 2x1, now I go to the equation of the line. Given equation of line is 4x minus y plus 1 is equal to 0. So I can say that y is definitely equal to 4x plus 1. So I compare with the general equation y is equal to mx plus c, and I can say that slope of line is equal to 4. But tangent is parallel to the line, therefore slope of tangent is equal to slope of line, that is equal to 4. And normal is perpendicular to the tangent, therefore slope of normal is equal to minus 1 upon slope of tangent, that is equal to minus 1 upon 4. Now using equation 1, slope of tangent, which was equal to 2x1, I can now write over here 4 is equal to 2x1, therefore x1 is equal to 2. See, we are using this equation over here, 2x1, which is the slope of the tangent, and we have found out that the slope of the tangent is 4, so we are equating these both values over here. After this point over here, which is p x1 comma y1, lies on this particular curve, therefore the value of x1 must satisfy the required equation of the curve. We will say over here, since px1 y1 lies on the curve, it must satisfy equation of the curve, therefore y1 is equal to x1 square, and it is plus 5, therefore y1 is equal to 2 square plus 5, and hence y1 is equal to 9. Therefore px1 comma y1 comes out to be equal to 9. Now after this, guys, I can find out the equation of tangent and also the equation of the normal. x1 y1 is equal to 2 comma 9, and the slope of the tangent that we had obtained is equal to 4, so I write m is equal to 4. Therefore By slope point formula, y minus y1, which is equal to m into x minus x1, carefully we substitute the y1 value as 9, m as 4 and x minus 2. Y minus 9 is equal to 4x minus 8. Take these both elements on the opposite side, so y becomes negative and 9 becomes positive. Therefore 4x minus 9 y plus 1 is equal to 0, plus 9 and minus 8. So students, that is our required equation of the tangent. Now we can find out the equation of the normal. The point px1y1 remains same, so I can say over here that x1 comma y1 is 2 comma 9, and we had seen that the slope of the normal was minus 1 upon 4. Therefore again by slope point formula, y minus y1 is equal to m into x minus x1 is, so it is y minus 9 is equal to minus 1 by 4 into x minus 2. So I will get over here, therefore 4y minus 36 is equal to minus x plus 2. Therefore take these both elements on the opposite side, x becomes positive, plus 4y minus 36 minus 2, that is equal to minus 38, and that is equal to 0. So sum number 3 over there says find the equation of tangent and the normal to the curve y is equal to 3x square minus 3x minus 5, where the tangent is parallel to this particular line, whose equation is 3x minus y plus 1 is equal to 0. Once again students, let us first understand this with the help of a small diagram. If this is our required curve, whose equation is y is equal to 3x square minus 3x minus 5, and we have a tangent which touches the curve at this point. There is a line which is parallel to the tangent, let's say like this, whose equation is given to us as 3x minus y plus 1 is equal to 0, and the normal as usual is perpendicular to the tangent. So in that case we start with writing our required point px1 y1 like we did in the previous case. We say that let px1 y1 be the required point on the curve where tangent is parallel to the line 3x minus y plus 1 is equal to 0. So in that case, we start with equation of curve, which is 3x square minus 3x minus 5. Differentiate this with respect to x, so you get dy by dx. Derivative of this is 6x minus 3. Now, slope of tangent over here, as I told you in the beginning, it is dy by dx at x1 comma y1. So in place of x, we substitute the value as x1. So I will get slope of tangent is equal to 6x1 minus 3 and give it as equation number 1. Now, we know that tangent is parallel to the line 3x minus y plus 1 is equal to 0. So, we say over here, consider 3x minus y plus 1 is equal to 0. So, in that case, I get y is equal to 3x plus 1 and compare this with y is equal to mx plus c, and I can say that slope of line is equal to m, which is equal to 3. Therefore, slope of tangent is also equal to 3 since the lines are parallel to each other. Now, because I know that the slope of tangent is 3, I can substitute this in equation 1. So now we will say over here, using equation 1, 3 is equal to 6x1 minus 3. To transfer this, so it becomes 6 is equal to 6x1, and therefore guys, x1 comes out to be equal to 1. Now, as I told you in the beginning, that this is our point P, x1 comma y1. It lies on this particular curve. So this value of x1 must be satisfying the equation of the curve. Say over here, since Px1 y1 lies on the curve y is equal to 3x square minus 3x minus 5. Therefore, it should satisfy equation of curve. Therefore, y is equal to 3 into x1 square. In fact, y1 is equal to 3 into x1 square minus 3x1 minus 5. So it is 3 minus 3 minus 5, which is equal to minus 5, is equal to y1. Therefore x1 comma y1 is equal to 1 comma minus 5. So after getting the value of x1 and y1, then we will be able to get the required equation of the tangent as well as of the normal. So first let us find equation of tangent. x1 comma y1 is 1 comma minus 5, and the slope of the tangent is equal to 3. So by slope point formula, y minus y1 is equal to m into x minus x1. Substituting the values very carefully, y minus negative 5, m over there is 3 into x minus 1. Open the brackets, y plus 5 is equal to 3x minus 3. Transfer these elements on the opposite side so their signs will change. So you should get this as 3x minus y minus 3 minus 5 minus 8 is equal to 0. So students, that is your required equation of the tangent. Now, as I know that normal is perpendicular to the tangent, slope of normal is equal to minus 1 upon slope of tangent. So this is equal to minus 1 upon slope of tangent is 3. So you get this is equal to minus 1 upon 3. Therefore for equation of normal, x1 comma y1 is already what we have found out it to be 1 comma minus 5, and m is equal to minus 1 upon 3. So by slope point formula, y minus y1 is equal to m into x minus x1. So y minus negative 5 is negative 1 by 3 into x minus 1. Therefore y plus 5 multiplied by 3 is equal to minus x plus 1. Carefully open these brackets, 3y plus 15, and take these both elements on the left side, so it becomes plus x minus 1 is equal to 0. Therefore what is the equation of the normal, guys? You will get x plus 3y plus 14 is equal to 0.